So, this story almost always gets told wrong. You hear Einstein, genius, a flash of insight, there's the theory. And, um, that's not what happened. It took 8 years, dead ends, a theory he published himself that was wrong, and a friend he had to beg for help with the mathematics. We start in 1907, at the patent office in Bern. Einstein is writing a review article, and a thought comes to him he later called the happiest of his life. He pictures a man falling off a roof, and that man, he doesn't feel his own weight. Sounds trivial. It isn't. In free fall, gravity is gone for you. And in a sealed, windowless box, accelerated upward in empty space, no experiment tells you whether you're accelerating or standing on the Earth. Gravity and acceleration are indistinguishable. That's the equivalence principle. It also explains something people had puzzled over since Newton. Why does everything fall at the same rate? The mass that resists a shove and the mass gravity pulls on are completely different things, and exactly equal. For Newton, a coincidence. For Einstein, the starting point. He draws conclusions at once. Send a light beam across the accelerating box and it lands lower on the far wall, because the box has moved on. So, gravity must bend light too, and clocks deep in a gravitational field must run slower than clocks high up. He writes that up in Prague in 1911. He also works out how far the sun bends a beam grazing its edge, just under 9/10 of an arcsecond. Wrong, exactly half the right value. A German expedition set out to measure it in Crimea in 1914 and walked into the outbreak of war. Had they measured, they'd have proved him wrong. Now, comes the step that changes everything. Einstein thinks about a rotating disk. Out at the rim, everything moves fast, so the rods shrink. The circumference measures differently from the diameter. The ratio isn't pi anymore. So the geometry isn't the one you learned at school. Space is curved. And that leaves him staring into an abyss, because he doesn't know the mathematics. In 1912, he goes back to Zurich, and there's that famous line to his classmate, Marcel Grossmann. Grossmann, you've got to help me, or I'll go out of my mind. Grossmann goes to the library and returns with something ignored for 50 years, Riemann's geometry, built out by Ricci and Levi-Civita. Tensors, a language for writing curvature down without committing to any coordinate system. In 1913, they published the Entwurf, the draft. And it's, almost right. The geometry is sound, but the field equations don't hold in arbitrary coordinates. He'd even had the right approach in a notebook and crossed it out. Why? Because of what he called the whole argument. He thought generally covariant equations couldn't fix the future uniquely. A mistake. What he missed is that points of spacetime have no identity without the matter in them. That error cost him 2 years. What pulled him out was an old anomaly, Mercury. Its orbit slowly turns, and a leftover of 43 arcseconds per century wouldn't come out of Newton. People had even invented an invisible planet for it, Vulcan. Einstein runs Mercury through the draft. Far too little. Then comes November 1915. 4 sessions of the Prussian Academy, 4 Wednesdays in a row. Einstein throws the whole argument overboard. On the 18th, he redoes Mercury, and out come 43 arcseconds. He wrote that he'd been beside himself for days. The same day, the light bending doubles to 1.7 arcseconds. On the 25th, the final field equation is there. Hilbert was chasing the same thing, and people have argued about it ever since. But the physical road there was Einstein's. So what does it say? On one side, the curvature of spacetime, on the other, matter and energy. Matter tells space how to curve, and curved space tells matter how to move. Gravity isn't a force anymore. It's geometry. And what came out of it? First, 1919. Two British expeditions photograph a solar eclipse in Brazil and on Principe. The stars near the darkened rim sit shifted by Einstein's value, not Newton's. A year after the war, Britons prove a German right. Second, the universe. Apply the equation to the whole thing, and it can't sit still. Einstein canceled that out at first, with a constant he later regretted. And in 1916, Schwarzschild, at the front, found a solution where curvature runs off to infinity: black holes. Third, the most everyday one: your sat-nav. Satellite clocks run faster because gravity is weaker up there, slower because they move fast, netting 38 millionths of a second a day. Without that correction, your position drifts 10 kilometers a day. And fourth, gravitational waves. He predicted them in 1916 and at times doubted they were real. On the 14th of September 2015, 100 years after those November days, two detectors caught two black holes merging, a signal smaller than 1,000th of a proton. What I like best isn't the result. It's the detour. A man falls off a roof, and 8 years later there's an equation that governs planetary orbits and corrects the clock in a satellite. In between, a wrong paper, a stubborn error, and a friend in the library. That's what thinking looks like when it works.